Next speaker who is ready to come and join us as well. I'm going to give a quick introduction to her before she comes on board. We have coming up next, we have Lindsey Rustad, and we are going to hear reflections on navigating a career in environmental science. So Lindsey is a research ecologist with the USDA Forest Service, and she has spent the last 3 decades trying to figure out what makes forests tick, and especially how these large-scale disturbances like climate change and extreme weather and pollution have been affecting those forest ecosystems. She has been awarded the USDA Forest Service Northern Research Station's Distinguished Science Award, as well as the Deputy Chief's Distinguished Science Award, and she is a fellow for soil science for the Society of America. So she's also a AAAS If Then ambassador. So with that, she has the opportunity to share how she's navigated her career in addressing some of these major environmental issues of our 20th and 21st century. And she uses all of her expertise to support women in science and provide girls and female in a STEAM role as a role model. So we are super excited to have you with us today, Lindsey, and I am going to bring you in. Welcome to the festival.
Hello there. Thank you for that great introduction, and I am going to share my screen. Let's see, now I need to share my share screen. Let's see if I can share my, oh, there it is. Got to share the right one.
Yes.
There you go. Okay. So, okay, so now I'm all set. So good morning, everyone. It is super great to be here, and thanks to everyone for tuning into the Women Blaze Trails Festival. As Liz said, I'm Lindsey Rustad, and I have indeed spent the greater part of actually the last 40 years trying to understand what makes forests tick, and particularly to understand how they respond to and recover from these really large-scale issues like air pollution, climate change, and extreme weather events. And what I want to do today is share with you my story on how I have navigated this lifelong career, including a little bit about my non-traditional background, how and why I made some twists and turns along the way, and some of the people I met, and then finally some of the lessons I've learned. So I am now a research ecologist with the USDA Forest Service, and I'm what you call the team leader for the Hubbard Brook Experimental Forest. And on most days, I will tell you, I have the very best job in the whole wide world. I get to work at one of the most famous watershed study sites, do crazy experiments like making our own winter weather events, rub elbows with world-class scientists, and even share the forest and occasionally the stage with artists. But it wasn't always that way. I started out as one of those odd ducks who studied in the liberal arts. I actually did my undergrad degree in philosophy at Cornell University in New York State. And I spent a lot of my time with the works of Plato and Aristotle and my favorite, Marcus Aurelius. However, contrary to some opinion, this was not a dead end. And it taught me the art of logic, the trick to look at a problem and look through it, under it, or over it. Of course, in philosophy and in many of the liberal arts, there often is never a right answer. And so when I had to take a science class to fulfill a distribution requirement, I was overjoyed to find that there were right and wrong answers to true, false, multiple choice, and even fill in the blank questions. And I got to take all kinds of natural science classes about birds and streams and forests. And all of these piqued my curiosity about the natural world. I was even more excited to find out that I could combine my interest in the natural sciences with my passion for the outdoors. I was a girl from the burbs, from outside of New York City, but my love was for the mountains, streams, and lakes, especially the Adirondack Mountains of New York State. So when I graduated from Cornell with that very useful degree in philosophy, all I wanted to do was spend a full year up in the Adirondack Mountains, watch the seasons go by, and honestly, just be a woman of the woods. As it turns out, and with a lot of serendipity, which means chance, I landed a job as a field technician on an acid rain project focused on 3 lakes in the very Adirondack Mountains that I love so much. And I landed that job because of one, a chance encounter with one of the project leaders, a man named George Hendry at Brookhaven National Lab, and two, the fact that I volunteered to work for free as an intern, which we could do back then. So, in case you haven't heard of it, acid rain refers to rainfall made acidic by air pollution, typically from the burning of fossil fuels. So, instead of having what we call a neutral pH, acid rain can be as acidic as lemon juice. And in the 1980s, we knew that acid rain could be harmful to forests and fish, but we had to figure out how. My job starting out was to wash sample bottles and to hike into 3 remote lakes to collect water samples. It was perfect. I had never taken a chemistry course, but I soon learned on the job about things like pH and alkalinity, the anions, sulfate and nitrate, the cations, calcium and magnesium, the many shades of dissolved organic carbon, and a mysterious metal called aluminum. I also met some of the luminaries of our field on those remote lakes. Jim Galloway, here on the left, clearly pondering something important, and Jamie Shanley on the right, fussing over one of the early automated water samplers that he fondly called Tubby. I also met people like Pete Murdoch and Charlie Driscoll and Chris Cronin and Dick Wright and Dak Hosby. The Acid Rain Project turned out to be a who's who of forest ecology, which was great for me because I met them all. And Jim Galloway, who I just showed you, ended up hiring me and paying me. And he invited me back to the University of Virginia, where I spent a month working at the famous White Oak Run watershed in the beautiful Blue Ridge Mountains, learning all about the mysteries of how to measure stream flow and watershed inputs and outputs. And serendipitously, Jim Galloway introduced me to a fellow philosopher scientist, a man named Herb Borman, who happened to be on sabbatical at the University of Virginia when I visited. Herb spoke to me about a mystical place called Hubbard Brook in another set of mountains in New Hampshire. And in fact, acid rain, which is what we were studying in the Adirondack Mountains, had first been discovered at this place called Hubbard Brook. And Herb encouraged me to apply to the Yale School of the Environment. And once accepted, I left my hermit home in the Adirondacks and I went to the city to learn about the forest. And it was there that I buckled down to catch up on foundational knowledge of water, watersheds, and ecosystems. And in addition to Herb Borman, I met the likes of Gene Likens, Tom Sikkema, and Garth Voigt, again, giants in the field of environmental science. And as a grad student, we took field trips up to that magical place I had heard about called Hubbard Brook. And for those of you who don't know about it, Hubbard Brook is about an 8,000-acre forested valley located up in the White Mountains of New Hampshire. It was established by the Forest Service back in 1955 as a place to study water for the region, and it has since grown to be one of the longest continuously running ecosystem study sites in the world. But it was there that I early had that epiphany of understanding that because forests, soils, climate, and geology change slowly, right, over decades to centuries to millennia, it was important to conduct long-term studies, at least on the scale of decades, to make these long-term changes seen and to understand what normal conditions are like so we can recognize when something is not normal, extreme, or just plain strange. At Hubbard Brook, I also learned about the small watershed approach, which was pioneered there by Herb Borman, Gene Likens, Bob Pierce, and Nori Johnson. What an amazing concept. It basically considered the watersheds at Hubbard Brook to be like a measuring cup. It assumed that they were underlain by a solid layer called bedrock, such that everything that was poured in would fill them up and eventually pour out. And then if you measured everything that went in the rain and everything that went out in stream water, and you analyze the chemistry of that water, you could multiply the two together and create these whole watershed nutrient budgets. It was simple, elegant, and powerful. And even more amazing, you could use this method to do whole watershed scale experiments. And that's exactly what they had done at Hubbard Brook. So holy moly, they started in 1965 and they cut down the forest in a whole watershed. They herbicided it for another 2 years and they left it to regrow. They learned many things, but 3 things that stand out are: 1, stream flow increased by over 50% during the 3 years of the treatment. 2, nutrients like nitrogen increased by up to 50 times during the same period. And 3, the ecosystem recovered relatively quickly when the forest was allowed to regrow. They went on to do more of these world famous watershed experiments. You can see the one on the right is the original one. The one in the middle was a strip cut, and the one on the left was another whole watershed cut. The results from the second 2 experiments reinforced what we learned from the first, including this concept that nature is resilient. So don't shudder. But here is the periodic table of the elements. And actually, I love this table, and I've grown fond of many of the colored boxes of the elements. So when I was at Hubbard Brook in the 80s, the heyday of acid rain, a lot of our research was focusing on the elements up here: hydrogen because of acidity, over here, nitrogen. Let's see if I nitrogen and sulfur because they turned to nitric and sulfuric acid. And then over here, the base cations, calcium and magnesium, because they're important plant nutrients and they neutralize acidity. And we were just beginning to learn about, again, this metal, aluminum. So aluminum has an atomic number of 13, atomic weight of 27, and has a property that at low pHs, like what happens under acid rain, it has a +3 charge, which makes it chemically sticky, reactive, and toxic to fish and plants. So at Yale, I worked with Tom Sikkema on the relationships between soil aluminum, root rot fungus, and tree health, and with the legendary gene lichens and the close association between aluminum and carbon in the tributaries of the Hubbard Brook. When I was ready to do my PhD, the acid rain spotlight was fully on aluminum, and I did my dissertation with Chris Cronin on the University of Maine on an aluminum biogeochemistry project. And my job was to better understand the biological cycling of aluminum, and I chose to do my work in the red spruce stand in Maine, where I set up my own mini watershed study on the slopes of Tunk Mountain. And I learned how truly sticky aluminum was in the soils and how tightly this element was retained in the landscape. It was like glitter, right? You get it on your hands and it sticks to you like static electricity, and you just can't shake it off. Meanwhile, the Aluminum Biogeochemistry Project was my first exposure to being part of a large international multi-investigator study, and I was intrigued by the power of doing studies across not only time, which I had seen at Hubbard Brook, but also across space. Before I go on, I have to admit that there was a darker side to those years. Starting out in philosophy, I felt I was at a disadvantage, especially compared to all these amazing grad students, postdocs, and senior scientists that I was meeting. And I didn't think I could ever be as good as them. I was suffering a significant case of imposter syndrome, though we did not know the term back then. This led to anxiety, stress, and eventually an eating disorder. I was one of the lucky ones, and I got professional help, and I was able to overcome it. But my message for the younger folks, or to anybody out there, is you're not alone, and there are good resources out there if you're struggling, and never, ever, ever be afraid to ask for help. So, going on, we were tackling acid rain in the late 80s, but we also recognized another environmental problem, and that was nitrogen. Nitrogen has an atomic number of 7 and an atomic weight of 14. And in forests, it has a peculiar property that if there is too little nitrogen, plants are undernourished and they don't grow very well. But if there's too much nitrogen, then the nutrition of plants gets out of whack and they also don't grow very well. So too little is bad. Too much might be worse. And we were learning that increased nitrogen in air pollution, that is acid rain, was adding too much nitrogen to our forests. And great thinkers like John Aber were sounding the alarm. And I became a part of that new wave of research on nitrogen. As I was finishing my PhD, I joined another large interdisciplinary team of scientists led by University of Maine researchers Steve Norton, Ivan Fernandez, and Steve Call, who were starting the Watershed Manipulation Project at the Bear Brook Watershed in Maine. The Bear Brook Watershed in Maine is a long-term paired watershed study similar to those I'd studied at Hubbard Brook, designed to study the effects of acid rain on a forest in Maine. In a nutshell, we added a small amount of nitrogen and sulfur by helicopter to one watershed every other month for 26 years, from 1989 to 2016. The adjacent watershed served as what we call the control. So results from this study have helped us refine our understanding of how forests respond to nitrogen and sulfur deposition and have informed air pollution policy here and in the US and all around the world. So now it's the early 1990s. We're still working on acid rain and nitrogen saturation, but we were eyeing the steady increase in atmospheric CO2 concentrations and beginning to understand the links between heat trapping gases like carbon dioxide and a warming climate. So Ivan Fernandez and I established one of the early soil warming experiments. This wasn't a watershed study, but it was a large plot experiment addressing how forests responded to warming. In this study, we learned how the warming of soil significantly changed carbon and nitrogen cycling, particularly through increased rates of processes like soil respiration, nitrogen mineralization, or litter decomposition. By the late 1990s, there was literally a worldwide explosion of global change experiments. And through some serendipitous encounters, a group of us met, and I had the opportunity to lead the establishment of an international research coordination network named TERAC, or Terrestrial Ecosystem Response to Atmospheric and Climatic Change. The goals of TERAC were simple: to synthesize the results from all of these hundreds of experiments and to bring people together from around the world to coordinate these efforts. Over 2 decades, we sponsored workshops, we helped build communication tools, we helped train the new generation of global change scientists, including a new cadre of women in global change science, and we published many, many papers. But the greatest value was bringing together the global community of scientists working on climate change. It was an exciting time, and I met and made friends with many men and women from all over the world. In the mid-1990s, although still working on Bear Brook, soil warming, and TERAC, I made the move to be a research ecologist at the Hubbard Brook Experimental Forest. And in the mid-2000s, I became the team leader for this amazing project. For someone who had been studying forest ecology for over a decade, it was then, and it is now, a dream job. At Hubbard Brook, I have the opportunity to be a steward of one of the longest continuously running ecosystem studies in the world. And I get to work almost daily with data from long-term monitoring programs, experiments, and models. And I've been able to continue my work on long-term watershed scale experiments, as well as conduct new experiments on forest drought, on warming, and even creating the first ever ice storm experiment. But at Hubbard Brook, it's more important to remember that it's filled with people, and people are what make the magic of science happen. And here's a shout out to the literally hundreds of people that make Hubbard Brook such a success, from students to staff to scientists to volunteers to visitors. So that's a full circle so far of my career. I hope there's lots more to come. But I'd like to end with some reflections on some of the lessons I've learned over the last 4 decades. So to start with my thoughts on science, the first is progression. The progression of science can be slow or can come in fits and starts. You have to be patient. 2, building blocks. The building blocks matter, laid on top of each other, one by one. Yours may seem not significant, but the whole is greater than the sum of the parts. Interdisciplinary thinking. Encourage this. Discoveries are often made at the interfaces of these disciplines. Think outside the box. That's usually where the big ideas are. And big ideas, don't be afraid to think big. Consider your idea first, dream about the best way to approach it, and then figure out how to make it happen. So, thoughts on people in science. Never, ever, ever underestimate the power and the joy of the people in science. So, embrace diversity of all kinds, even of intellectual backgrounds like us poor philosophy misfits. Be inclusive, be kind. You don't know what others around you are going through or suffering from, and you never know where those next big ideas are coming from. Encourage and take advantage of planned and chance encounters. Many of us, like myself, are introverts, but push yourself to meet people, even now on Zoom. You never know who are you going to meet, what ideas you will have, or what wild ideas they will spark in you. And some thoughts on the pursuit of science. Perseverance. It is super important to persevere. There will be ups and downs, budgets will be good or bad, administrations will come or go. You'll get through it. Don't give up. Life events. We all have life events, births and deaths and marriages and divorces, time for caring for young and old. Try to balance these with your pursuit of science. Give them the time they need, the time they deserve. When you die, you will likely not regret a sample you didn't take, but you might regret a loved one you did not see. Adversity. There may be illness, addictions, recoveries. Never fear asking for help. You are not alone. And never, ever, ever hesitate to give help when asked. Recharge. It's important to take time for yourself. Some of us are workaholics and we're go, go, go. But I've learned to take a break, recharge, empty my brain. And when I come back is always when I have the best ideas. Closed doors, glass ceilings. You may come across what you think is a closed door, maybe a glass ceiling. Don't accept that. Look for a way through, around, over, under. Keep at it for yourself and for those who will follow you. And serendipity. Always be open and welcome serendipity. You never quite know what's around the corner, what's going to happen, what course you're going to take. Allow for spontaneity and embrace the unexpected. My last thought I want to leave with you is if you've been tracking this, you may have noted that I've mentioned many, many men that were influential in my journey. I never had a mentor, actually, let alone a female mentor. In fact, it was rather lonely at times. As a good friend and colleague of mine, Dr. Mary Beth Adams said in a recent tweet, there were so few women in forest soils in the old days, but we were a catter, a team, and we stuck together, supported each other, and always lent a hand to the next woman or girl coming through the door. So much has changed, first slowly, and now the floodgates have opened with more and more women going into STEM and environmental science. And as these ranks swell, we can proudly stand up, stand tall, and show the girls what it's like to be a woman of science. And if they see it, they too can be it. And they can join the ranks of the next generation of STEM pioneers, and they too can change the world. The pursuit of science is an amazing calling. Thanks for listening to my journey, and good luck in yours.
Thank you so much, Lindsey. That is absolutely fantastic. And I love your final thoughts and all of those, the advice you gave. I think it's advice for life and such wonderful, wonderful things that you have shared with us. And what an incredible career you've had so far. And I look forward to seeing where it continues to go. So we do have a couple of questions that have come in on our live stream. So I want to go ahead and get started with some of those. So I'm going to pop it up on the screen so we can see it, and I can read it to you as well. So what advice would you give to early career conservationists that feel that they lack experience and confidence and worry that they won't be taken seriously?
Well, that's a great question. And I mean, that is exactly what I went through, right? So I started in liberal arts and philosophy, and then I made this change, and everybody around me was so experienced and so great and so wonderful. But just keep going, pick up the experience, follow your curiosity, really follow your passion, and layer by layer and brick by brick, you too will build that experience. When I was 32, I didn't have that experience, and I felt like I was never going to be good enough. But boy, just keep going, persevere, and enjoy the process along the way. This is supposed to be fun as well as helping the world.
Absolutely. I think that's spot on. We have another one that is wondering about your favorite place. So, what is the favorite place you have visited so far?
Oh gosh, that's a really tough one. Pre-COVID, I've had the chance through my work and through just enjoying traveling. I've enjoyed traveling to places all around the world, from the U.S. to Europe to China, to Chile to New Zealand, and oh my God, they're all unique and different. Um, I think I just like diversity, right? I like seeing new places. I like spending time in new forests. I spend a lot of time in the northern forests of New England, but to get to a tropical forest is amazing. To get to a grassland, to get to a mangrove, and see how they're all different. So I'm dodging the question, and I'm not telling you my favorite place. I'm telling you I like diversity of places.
Well, and I'm sure every time you go to a different place, you see something new and probably experience something new, and that just adds to your curiosity and love of the forests and earth. So, another question, the forest that you have been in, these experimental forests, the Hubbard Brook, is that a place that people could potentially go and visit, or is it just for scientists and researchers?
Oh, we welcome everybody. We welcome everybody. We are inclusive. We are not exclusive. Anybody that wants to come, find my email. I'll then invite you up, maybe after COVID. So it is a mecca for scientists, for sure, from around the world. And there's several of these big types of experimental forests, experimental ranges. So the U.S. Forest Service, for example, we run 81 of these across the U.S. The National Science Foundation in long-term ecological research, they have 26. So you can look these up and find one near you. And I think people at these places are all happy to meet you, to show you around, or your class, or interact. There's a lot of folks who are super welcoming. So they are not closed. We welcome people to come visit. We welcome educators and students, and we really welcome new scientists and researchers. It's not a closed door, it's open.
Oh, that is so fantastic to hear. I'm sure that a lot of people will be headed to those websites to come and visit. I know I myself am dying to come up to Hubbard Brook once I can leave Massachusetts. So we'll get there eventually. We have another great question coming in on the live stream that I'm going to pull in as well. That is from Charlotte on any advice for a high school senior interested in environmental science.
Sure. Wow, you already have this interest. It's really, get out and, see if you can get involved in some conservation work in your own community. Um, See what you can find on the internet, but just really explore your own backyard, your own world, and look at all the interrelationships between things. I think the best thing you can do is foster your own curiosity, and then you can build the educational building blocks as you need as you go. Those will come. But it's really that curiosity, that exploration, right, by the seat of your pants, that is the best thing to be doing right now, I think.
And kind of to follow up on that, you spoke about perseverance and collaboration quite a bit as well. And as someone who you were out in the field in this soil science and watershed ecology, kind of trailblazing yourself, were there problems that you encountered? Were there any kind of in your field work, something went wrong, and then you had to kind of, as you said earlier, look through, look under, look over a problem and try and solve it? Is there an example you could share with us of something that you weren't expecting in the field that happened, and how you all worked to fix it?
Oh, that's a good question. So I think some of the challenges have been, and I said this before, is when you have an idea, you have a big idea. We think of their big ideas, right? And then you have to dream big. right, to how you're going to address it and then actually make it go out and find out how to make it happen. So my example is the ice storm experiment. So I study climate change and extreme weather event. And here in New England, one of the types of extreme weather that we have are ice storms. And we don't know much about ice storms. And so it was like, God, how do we study ice storms? And my colleagues and I thought we'd be ice storm chasers, like tornado chasers. And we realized that wasn't really going to be pragmatic, because I had 3 kids and a family and blah, blah. So anyway, we decided to create our own. And so we thought big, and we went out to Hubbard Brook in our outdoor laboratory, and with fire hoses and pumps, we created the first ever ice storm experiment. But it was collaborative. It was a group, all of us thinking together, could we do this? How could we do it? And then actually being daring enough to go out and try it. So I think just, think of your ideas, think what's the best way you can address it, and then figure out how to make it happen.
I love it. I'm a teacher myself, and one of the things I always say when brainstorming, think big, and every single idea is welcome and valid. And then once we get all the ideas out there, we'll see what works. We'll test them, and it's okay if they fail, because you learn from your failures as much as your successes. So I'm curious, just last question, if you have a project you're working on next that you're excited about, or something you're thinking about you want to study next.
Oh, well, you know what I'm doing? I'm actually working with an artist, a wonderful artist from Brooklyn named Nikki Lint, and we're beginning to listen into the below ground. So I'm a soil scientist. We've studied soils for 4 decades, but we've never heard anything. So we're beginning to listen to the deep resonant sounds, earthworms munching, roots growing, and developing below ground soundscapes, which I hope I'll be able to share with all of you in the next year or so. Watch out for it. So
That
below
sounds
ground
amazing.
sound.
It sounds amazing. We'll have to have you back once you have it all ready to share. Well, thank you so much, Lindsey, for joining us today. It was absolutely fantastic learning about your career and all of the advice that you have given as well. So thank you so much for joining us.
Thank you very much for having me, and have a great rest of the festival.
Thank you.